Hello everyone. Today I would like to share with you a new feature in OceanBase version 4.3, tenant cloning. Let's start by walking through a few scenarios. Imagine during a busy promotion, the business is thriving with high sales and the manager requests a report on the overall sales situation. However, the database's CPU utilization has already reached 85%. In this scenario, should we take the risk of running the database or perhaps manage the manager's expectations? Now consider another situation. Despite the high pressure on the production tenant, the internal operations system continues to send uncertain and complex queries. Is there a way to quickly remove these complex query workloads from the production tenant? Here's another one. Before upgrading the business version, it's crucial to back up the database before deploying the application version. If an exception occurs during the application version release, is there a simple and easy way to restore the database and roll back the version? Now, the tenant cloning feature is introduced in OceanBase version 4.3 to address these challenges we've discussed. In OceanBase, a tenant is similar to an instance in traditional databases. For example, OceanBase supports MySQL-compatible tenants. From a client's perspective, using a MySQL-compatible tenant is similar to using a traditional MySQL database instance. The multi-tenant feature is introduced since OceanBase version 1.0 and has become very robust and mature. The 4.3 version brings a new feature on top of the existing multi-tenant architecture, tenant cloning. This statement is used for tenant cloning. When the statement is executed under the system tenant, a new tenant can be quickly cloned based on the source tenant. Just as the term cloning suggests, the data contained in the newly cloned tenant at the initial moment is a snapshot of the source tenant at the time the statement was executed. The operation of cloning a tenant can be compared to the fork operation of a process. In a fork operation, the parent process copies the page table information to the child process, allowing the child process to initially access the same physical pages as the parent process. Similarly, during tenant cloning, the metadata of the source tenant is copied to the newly cloned tenant, allowing the newly cloned tenant to access the same physical macro blocks as the source tenant at the initial moment. A macro block is a data storage unit in OceanBase, as shown in this slide. Because only the metadata is copied during the entire cloning process, without actually duplicating the data, the cloning operation can be completed very quickly. In our testing environment, it only takes 2 minutes to clone an 8-core 64GB tenant from a tenant with the same configurations and 500,000 tables. The newly cloned tenant and the source tenant are completely independent. They have their own CPU, memory, and IOPS resources and do not affect each other. For the reporting task, we can easily clone a new reporting tenant based on the production tenant. This new reporting tenant has its own CPU, memory, and IOPS resources, allowing us to run reporting tasks with minimum impact on the production tenant. Starting from version 4.3, OceanBase introduces the hybrid row-column storage mode. If the source tenant is in the hybrid row-column storage mode, the newly cloned tenant will also be in the hybrid row-column storage mode, thereby providing excellent support for AP workloads. To remove complex queries from the production tenant, we can clone a new tenant based on the production tenant and set the new tenant as the standby tenant of the production tenant. This way, the new tenant will proactively replay logs from the production tenant, allowing it to provide quasi-real-time weak read services. Then, the complex query workloads from the internal operational system can be transferred to the newly cloned read-only standby tenant. For application version upgrades, we can quickly clone a pre-release test tenant based on the production tenant for final pre-release validation before the version is released. Usually, the first step of version release is to back up the database. In version 4.3, this can be adjusted to quickly clone a small standby tenant based on the production tenant. If, unfortunately, there is a problem with the version release, a new production tenant can be cloned using the newly cloned standby tenant, achieving rapid database restore. Because the cloning operation is extremely fast, the tenant cloning technology can minimize the time required for version release. Multiple new tenants of different specifications can be cloned from a single tenant, which can be applied in different scenarios. So far, we have introduced some scenarios for tenant cloning. Now let's move on to its implementation. The tenant cloning process can be divided into 2 steps. The first step is to create a crash-consistent snapshot of the source tenant. The second step is to launch a newly cloned tenant based on the crash-consistent snapshot. As we can see, the tenant cloning process is based on a consistent snapshot. But how can a crash-consistent snapshot be created in a distributed database with a shared nothing architecture? This slide shows the snapshot model of a distributed database. Each database has many equal nodes, each with its memory cache, persistent log files, and persistent data files. In typical scenarios, data modifications are performed in memory, and when necessary, the logs are persisted to log files. There are also scheduled checkpoint tasks to write modified data from memory to data files and record the starting point for log replay in case of a crash known as the checkpoint. Additionally, there is usually a highly reliable and available global timestamp service across multiple nodes to ensure overall external consistency of the distributed database. Based on these existing components and mechanisms in the distributed database, the snapshot creation process involves the following steps. First, record the current checkpoint of each node. Second, back up the metadata of data files from each node and reference the data through the metadata. Third, determine the snapshot point, also known as the consistent snapshot point, using the global timestamp service. Once these steps are completed, the data files saved by each node, along with the log files from the checkpoint to the snapshot point, compose a crash-consistent snapshot. We can then create a newly cloned tenant based on this snapshot. Each node of the newly cloned tenant uses the saved data files as its initial state and replays the logs from the checkpoint to the snapshot point to ensure that each node accurately updates its state to the snapshot point. The entire tenant cloning process does not interrupt the normal SQL execution of the source tenant. Now, let's elaborate on how does tenant cloning work in OceanBase. First, let's look at the logging part. OceanBase uses its log archiving mechanism to manage logs during the cloning process. After each node of the newly cloned tenant is started, it accesses the archived logs of the source tenant, reads and replays the logs from the checkpoint to the snapshot point, thereby uniformly updating the states of each node to the snapshot point. Next is the data part. Starting from version 4.0, OceanBase organizes data in the form of tablets. Each tablet references the physical macro blocks it needs, and the data is eventually stored in these physical macro blocks. During the cloning process, the metadata of each tablet of the source tenant is copied to generate metadata for the newly cloned tenant, and the reference count of each associated physical macro block is incremented. Lastly, as previously mentioned, OceanBase uses a global timestamp service, GTS, to obtain the final consistent snapshot point. This slide provides a demo of tenant cloning. As indicated in the blue text, executing a clone statement under the system tenant quickly clones a new tenant from the source tenant. Meanwhile, any data changes in the source tenant do not affect the newly cloned tenant and vice versa. This is what we call tenant isolation in OceanBase. Here is a complete demo of the tenant cloning process. The screen is divided into 3 parts. The top section displays operations under the system tenant, similar to a traditional database instance. The middle sections are for operations in the source tenant, and the bottom sections are for operations in the newly cloned tenant. First, look at the middle sections. On the left, we will use Sysbench to perform read and write performance testing on the source tenant. On the right, by querying the internal table, we can see that log archiving is enabled for the source tenant, which is necessary for the tenant cloning functionality. Additionally, in the source tenant, there's already a table named clonetest.clonetest with data entries 1, 2, and 3. At the top section, we log on to the system tenant and initiate the tenant cloning operation. The cloning process does not block the regular SQL execution of the source tenant. You can see that the queries per second, QPS, of the source tenant remains relatively stable during the cloning process. The newly cloned tenant is initially in a read-only state. However, we can switch it to a primary tenant, that is, a regular read-write tenant. Let's wait a moment. Alright, the tenant cloning is completed, and cloned tenant is switched to a primary tenant. Let's take a look at the bottom sections. On the left, we run a ClickBench workload test on the newly cloned tenant. This script executes a CPU-intensive AP operation. As the test progresses, we observe that running ClickBench on the newly cloned tenant has minimal impact on the sysbench performance of the source tenant. Moving to the right, we log on to the newly cloned tenant, successfully query the clonetest.clonetest table, and update the data in this table. In the upper window of the source tenant, we query this table and find that no data changes. We then proceed to drop this table. It's clear that the newly cloned tenant below remains unaffected, demonstrating the strict resource and data isolation between these two tenants. To summarize, tenant cloning offers several key advantages. First, it's fast. Only metadata information is copied during the cloning process, making it very fast. In our testing environment, it only takes 2 minutes to clone an 8-core, 64GB tenant from a tenant with the same configurations and 500,000 tables. Second, its ease of use. As shown in the demo, you only need to execute one cloning statement under the system tenant to complete the cloning. Also, OceanBase's tenant cloning is fully implemented within the database kernel, eliminating the need for external storage system support. You can simply run OceanBase version 4.3 on your regular machines to use the tenant cloning feature. Third, it's stable. The entire cloning process does not block the regular SQL executions of the source tenant. The newly cloned tenant and the source tenant remain independent with strict data and resource isolation, ensuring no mutual interference. Last but not least, it's cost-saving. The newly cloned tenant maximizes the sharing of physical macro blocks with the source tenant, saving storage resources as much as possible. Okay, so much for the introduction to OceanBase's tenant cloning. Thank you for watching. Goodbye.